my PU2 2026 aspirants, so your midterm is ahead. And yes, we have already completed the one shot from the chapter Electrochemistry. So today now we are going to solve the 1 marker questions from this chapter. Okay, so there are almost 40 plus MCQs and 30 plus you can say FIBs are there, fill in the blanks. So let's get started with the first question. So first question which I have taken is from the sample paper of 24-25, and there will be only one marker question according to the blueprint. Okay, so that one marker question can either be in your FIBs or can either be in the MCQs. Let us see the first question. E0 values of Fe2 plus Zn2 plus Sn2 plus are this. Which metal is or are can be act as a sacrificial electrode to protect iron from rusting? So now if you see that what is sacrificial electrode means what? That will undergo reduction or reaction faster. Okay, sacrificial, we definitely know that zinc can be used as a sacrificial electrode because it will undergo reaction faster. So if you see Fe value is minus 0.44, Zn value is minus 0.76. right, the reduction potential values are there. Now if you consider their oxidation potential, then you see that Zn has more oxidation potential than iron. So if Zn is having, so let me just write down in that form of oxidation potential. So rusting is what? Rusting is a oxidation of metals, right? Metals get oxidized in this process. So now let us first write their oxidation potential. So if you see, I write for Fe, one second. So if I write for Fe to Fe2 plus, what will be the value here? Plus 0.44. Then if you have Zn to Zn2 plus, its value will be plus 0.76. Then if you have Sn to Sn2 plus, okay, that is equal to plus 0.14 volt. Clear? Now if you see that the oxidation potential of zinc is more than Fe, whereas Sn is less than Fe, right? So zinc will undergo oxidation faster than Fe and can protect Fe. So that is why the answer will be only zinc, that is option number B. Now next question, a galvanic cell has an electric potential of 1.1 volt. If an opposing potential of 1.1 volt is applied to the cell, what will happen to the cell reaction and current flowing through the cell? So what will happen? The cell reaction stops and no current flows. Reaction continues but current flows in opposite direction. Concentration of reactants become unity and current flows from cathode to anode. The cell does not function as a galvanic cell and zinc is deposited on the zinc plate. So we know that when an electrode potential of 1.1 volt greater is applied, the reaction will continue and the current flows in opposite direction. Now moving to the next question number 1 here from the PU board question bank, I have taken 30 questions. Which of the following statements associated with electrochemical cell is incorrect? The function of a salt bridge in an electrochemical cell is to complete the circuit. Yes, that is a correct statement. The cell potential is the potential difference in a voltaic cell. Yes, that is also a correct statement. A Bronsted-Lowry acid-base reaction can be the basis of the net reaction in a chemical cell. So we have studied that redox reactions are the basis for the chemical energy to electrical energy, not the acid-base reaction. So this is the incorrect statement. So let us see the next question. The standard electrode potential E0 values of aluminium, silver, potassium and chromium are given. The correct decreasing order of reducing power of the metal is. So first let us write down all these values. We have aluminium 3 plus 2 aluminium. Then we have silver Ag plus 2 Ag. Next we have K plus 2 K. And then we have Cr plus 3 to Cr. So here we have Al3 plus is minus 1.66 volt, Ag plus is 0.80 volt, K plus is minus 2.93 volt and chromium is minus 0.74 volt. Now what you can observe, the question is asking decreasing order of reducing power, means it will reduce others, itself it will get oxidized, right? Reducing power means reducing others, itself getting oxidized. Now these are the reduction potentials. The one whose reduction potential is least will have the maximum oxidation potential, right? So where I can see the least reduction potential, you can see K plus is having the least reduction potential. So that means this will have the highest oxidation potential. So if it can undergo oxidation faster or in the best way, it will behave as a best reducing agent. Okay, so that is why K will be at the highest. I can eliminate these two options. Now you see in both the option here the last element is different, so we have to just check the last element, then we can get the correct answer. So we need now least reducing power. Okay, means it should have the highest or reduction potential. So where I can see highest reduction potential, you can silver here, highest reduction potential means it will reduce better, oxidize, its oxidation will be very slow, so it will also behave as a very weak reducing agent or reducing power. So option number C is the correct answer. Next question, a button cell is used in watch functions as the following half cell reactions are given, cell potential will be. So you can see in the reaction Zn is undergoing oxidation. So Zn is what? Zn is anode, and you can see silver is undergoing reduction, so silver is cathode. So what is the cell formula? E naught of the cell will be equal to E naught of cathode minus E naught of anode. So what is the cathode formula is 0.34 minus anode is minus 0.76. Now if I add this, I'll get 1.1 volt, which is option number C. Next, the standard reduction potentials are given. The strongest oxidizing and reducing agent respectively are. So if you see that reduction potentials are given, right? Reduction potential means they are undergoing themselves reduction. If they are undergoing reduction, they will behave as an oxidizing agent. So the one whose reduction potential is maximum, it is undergoing best reduction, will behave as best oxidizing agent. So let us see whose reduction potential is maximum. F2 reduction potential is maximum, it can undergo best reduction, and when it is undergoing reduction, it will behave as an oxidizing agent. So F2 will be the best oxidizing agent. So I have only one option with F2, so that is why option number A here. Next, the standard electrode potential for SN4 and CR is given. These two couple in a standard state are connected to make a cell. The cell potential is. So if you see what is the reduction potential of SN4 plus to SN2 plus. The reduction potential is 0.15 volt, and then you have Cr plus 3 to Cr. What is the value here? Minus 0.74 volt. The cell potential will be. So if you see the reduction potential here is maximum, so where the reduction potential is maximum, that will behave as cathode, another will be anode. So what is the E naught of the cell? Cathode minus anode. So we have 0.15 minus 0.74, which is equal to 0.15 plus 0.74, and that is equal to 0.89 volt. So we'll get option number C here. Moving to the sixth question, consider the following relations of EMF of an electrochemical cell. The EMF of the cell is given. So let's first discuss what is EMF of a cell. So E naught of the cell is equal to, okay, E naught of oxidation plus E naught of reduction. Okay, that is the general formula. Now let's see first, EMF of the cell is equal to oxidation potential of anode. Oxidation potential, oxidation takes place at anode. So oxidation potential of anode minus reduction potential of cathode. No, it is not minus reduction potential, it is plus reduction potential of cathode. So this equation is wrong. Next, EMF of the cell is oxidation potential of anode plus reduction potential of cathode. Yes, that is correct. Next, EMF of the cell is equal to reduction potential of anode plus reduction potential of cathode. Now when you are taking the reduction potential, you have to change the sign, okay? So that because anode is where oxidation takes place. Now if you are taking its reduction potential, it has to be minus, okay? So that is why this statement is also wrong. E naught of the cell is equal to oxidation potential of anode minus oxidation potential of cathode. Yes, see, oxidation, anode undergoes oxidation, so oxidation potential of anode, you should have reduction potential of cathode. But yes, if you are taking the oxidation potential of cathode where reduction takes place, then the sign should change. So that is why this is also correct. So I have 2 and 4, which is option number D. Next, based on the following E naught values, the strongest oxidizing agent is. So if you see, we have strongest oxidizing agent, right? So strongest oxidizing agent means it will oxidize others, itself it will get reduced. So their reduction potentials are given to me. So reduction potential of this one is higher, FeCN6, this value is higher, right? FeCN6 4 minus, here it is. 1 second, FeCN6 4 minus, so here I'll get Fe plus 2 and here I'll get Fe plus 3 actually. Okay, so this is given to me as oxidation potential and this is the reduction potential, right? Now this is also oxidation potential. Both are oxidation potentials given to me, right? Fe plus 2 to plus 3, here also Fe plus 2 to plus 3. Now the question is, which is the strongest oxidizing agent? Means it will oxidize others, itself it will get reduced. If it is getting reduced, then its oxidation potential should be lesser, right? So I'll just explain this one. See, if the oxidation potential is higher, then oxidation is higher, oxidation is stronger. If it undergoes oxidation, it will behave as a strong reducing agent. Now if oxidation potential is lower, if oxidation potential is lesser value, then it undergoes reduction better, it undergoes reduction better, and if it undergoes reduction, it is a strong oxidizing agent. Now the question has asked us about oxidizing agent, means we should see which one is undergoing reduction better. To undergo reduction better, its oxidation potential should be less. Now if I see these two values, this is a lower value, so this one is undergoing oxidation potential is having less here, so this reduction will be easy, and when this reduction will be easy, it will be a stronger oxidizing agent. So which one will undergo reduction? Fe3 plus will undergo reduction, right? So the correct answer here will be option number A. Next, which of the following statements about galvanic cell are not true? The cathode carries a positive sign, this is true. Anions migrate towards the cathode. Let's see, the electrons are released through the anode, this is true. Reduction occurs at anode, this is false. So reduction does not occur at anode, oxidation occurs at anode. Anions migrate towards the cathode, no, anions do not migrate. So there is 2 and 4, which is again option number D here. Next, a solution of potassium bromide is treated with each of the following, which would liberate bromine. So you know that chlorine is more reactive than bromine, so chlorine can displace bromine from KBr, so it is option number C. Next, electrolytic cells are electrochemical cells in which non-spontaneous reactions are forced to occur by the input of electrical energy. Next, if the E naught of the cell for a given reaction has a negative value, which of the following statement is correct? So you have delta G is equal to minus NF E naught of the cell. Now E naught of the cell is negative, so we will get delta G is equal to positive NF E naught of the cell. So delta G value will be positive, okay? Now if delta G is positive, what will happen? If you know I can write like this, E naught of the cell is equal to 0.059 by N log K. Now what happens if E naught of the cell is negative? That means this value has to be negative, and for log value to be negative, K, the value should be less than 1. So K is less than 1, which is option number A. Next question, the name of the equations showing the relation between electrode potential, standard electrode potential and concentration is your Nernst equation, option number B. Next, what occurs when an atom is oxidized in a chemical reaction? When there is oxidation, so there is loss of electrons, okay, and increase in oxidation number. So this part is wrong. Loss of electrons and increase in oxidation number, option number B. Next, standard cell potential is measured at 25 degrees Celsius, concentration is 1 molar, 1 atm, yes, all of them are correct, so option number D. Next, which of the following statements are associated with corrosion is incorrect? Iron corrodes more readily than aluminium because iron is more reactive than aluminium. Cathodic protection prevents corrosion, yes, that is correct. A corroding metal has both anodic and cathodic areas, that is also correct. Corrosion involves both oxidation and reduction, that is also correct. Now here iron corrodes more readily than aluminium, this part is definitely correct, but not because iron is more reactive than aluminium. Aluminium is more reactive than iron. Aluminium is more reactive than iron, but what is the difference here, or why iron is then more prone to corrosion or more corrodes more readily? That is because when aluminium reacts with oxygen, it forms aluminium oxide, a layer outside it which prevents further corrosion. Okay, so that is why option A is the incorrect statement. Next, in the lead storage battery, a reversible reaction can occur, yes. Lead is oxidized to create a flow of electrons, yes. Lead forms the cathode when it is being reduced, that is also correct, all the above, option number D. Next, a voltaic cell has E naught value of -1 volt. The reaction is, so if it is negative, then your delta G value will be positive because delta G is minus NF E naught. Now this E naught is also negative, so negative it will be positive, so it is non-spontaneous. Okay, sorry. So has a positive G value. I can erase this one. It will have a positive G value. Next, which of the following is false regarding the salt bridge used in voltaic cell? The salt bridge allows the two half cells to be kept separated, yes. Maintains the electoral neutrality, yes. Allows mixing of two electrode solutions, no, it keeps it separate, right? So that is why option number C. Next, the advantage of fuel cells include, they can be recharged by the addition of more material, yes. They can be made to produce no harmful pollutants, yes. They can be made to run very quietly, yes. All of the above, that is option number D. Next, an aqueous solution of NaCl on electrolysis. Aqueous solution will give you H2Cl2 and NaOH. Next, limiting molar conductivity of NH4OH. So this particular example I have given you in the one shot video also. So that is equal to NH4Cl plus NaCl minus NaCl, NaOH minus NaCl, option number D. Next, which of the following expression correctly represents the equivalent conductance at infinite dilution, given that Al3 plus and SO4 2 minus are equivalent conductance. So when equivalent conductance is given, it is the direct value. So you should not have multiplied this 2 aluminium or 3 sulfate. That is when molar conductance is given. For equivalent conductance, you have to take the exact value. Next, Coulter's law states that at infinite dilution, each ion makes definite contribution to conductance of an electrolyte, whatever be the nature of the other ion. Yes, that is correct. Next, at infinite dilution, each ion makes definite contribution to equivalent conductance. No, it makes contribution to the conductance. So this is wrong. Finite dilution, wrong. Infinite dilution, each ion makes definite contribution to equivalent conductance of an electrolyte depending on the nature. No, it doesn't depend, and it doesn't contribute only to equivalent conductance. So both option A is correct. Next, on electrolysis of dilute sulfuric acid using platinum electrode, the product obtained at anode will be your oxygen gas. That is option number B. Next, we have 0.1 mole of MnO4 2- is oxidized. The quantity of electricity required to completely oxidize MnO4 2- to MnO4-. Now, if you have MnO4 2- to MnO4-, so it is +6 to +7, right? +6 to +7 is how much? 1 Faraday. 1 Farad is equal to 96500 coulomb. Right now, for 1 mole you need 1 Faraday or 96500 Coulomb. Now for 0.1 mole, how much will be required? 0.1 Faraday or 9650 Coulomb will be required. Next, a device that converts energy of combustion of fuels like hydrogen and methane directly into electrical energy is your fuel cell, or option number C. Next, zinc can be coated on iron to produce galvanized iron, but the reverse is not possible. It is because zinc has higher negative electrode potential than iron. Okay, so the reduction potential of zinc is more negative. That means it is more tendency having more tendency to get oxidized. So zinc is covered on iron, then zinc will oxidize better and it will protect the iron. Moving to 28th question, the most convenient method of protection the bottom of the ship made of iron is. So it is white tin plating, which is option number B here. Next, to protect iron against corrosion, the most durable metal plating on it is your zinc plating. Lastly, in a dry cell, the graphite rod is a negative terminal. That is correct. A graphite rod is a negative terminal. The ammonia gas accumulates in the cell during its working. So ammonia cell does not, you have to find the correct statement. Okay, so this is a wrong statement. It is not the negative terminal. The ammonia gas does not accumulate because it forms complex. The zinc vessel is a negative terminal, yes, because zinc undergoes oxidation, so it is a negative terminal. The cellular reaction involves the complex formation of zinc with MnO2, no, it is with ammonia. Okay. Moving to the next, we'll do some question from last year. 2 questions are there. So 2023, on charging the lead storage battery, PbSO4 on cathode is reduced to Pb. Next, we have how many electricity in terms of Faraday is required for 1 mole of aluminium to form aluminium 3+. So 3 moles of electrons are there. So 3 Faraday, option number C here. Now we'll go to the next part of the question, that is fill in the blanks questions. Okay, so I have some sets of fill in the blanks here. In galvanic cell, the electrode which acts as an anode is a negative pole, right? The galvanic cell, the anode is negatively charged. In lead storage battery, the cathode consists of PbO2. Okay, next, in Leclanche cell, MnO2 acts as a depolarizer. Next, you have protection of iron by coating with zinc is called as galvanization. The arrangement in which electrical energy supplied brings about a redox reaction is called as electrolytic cell. Next, we have zinc replaces copper from copper sulfate solution because the standard reduction potential of zinc is dash than that of copper. So it replaces copper, means copper is undergoing reduction, zinc is undergoing oxidation. So if you see, the reduction potential of zinc is less than that of, it is less. Why it will be less? Because zinc is undergoing reduction, right? Sorry, copper is undergoing reduction, so that will be less. Next, if the value of standard electromotive force E0 of a cell of a galvanic cell is dash, then the cell reaction will be spontaneous. If it is negative, then only the, sorry, one second. The E0 of the cell should be positive, then the cell reaction will be spontaneous. Next, we have the cation and anion of the electrolyte used in the salt bridge have equal mobility. Next, during electrolysis of an aqueous sodium chloride solution, dash is produced at the cathode. So, aqueous solution, hydrogen will be produced. You have aqueous sodium chloride at cathode, right? So, cathode hydrogen will be produced because H plus ions will move. During electrolysis of a fused sodium chloride, dash is produced at cathode. Fused sodium chloride means only sodium chloride is there. So, sodium will move. So, that one will be produced sodium. Okay. Moving to the next one, NaCl solution conducts electricity, but urea cannot conduct electricity because it is a non-electrolyte compound, means it does not have its own ions. The unit of cell constant of a conductivity cell is centimeter inverse. Acetic acid is a weak electrolyte. Rusting of iron is an electrochemical process. Lead storage battery is used in automobiles. Next we'll see, in any electrochemical cell, the dash is always the electrode at which some species gain electrons. So gaining of electrons, it is the cathode. Okay. Next you have the site of oxidation in an electrochemical cell is anode. At anode, oxidation takes place. Next, dash is used in pacemakers, electronic watches and hearing aids. So that is your mercury button cell. Next, dash is defined as the amount of substance deposited or liberated at the electrode by a charge of 1 coulomb, that is electrochemical equivalent. Metal used as a coating on steel to limit corrosion is your zinc. Next we have the positive E0 value shows that the reactions are spontaneous. Next, electrolysis is a process in which the electrical energy is used to cause a electrolysis. It is, one second, the positive E0 value shows that the reactions are spontaneous. Yes, electrolysis is a process in which the electrical energy is used to cause a non-spontaneous chemical reaction. The reference electrode SHE has EMF of exactly 0 volt, right? When diluted sulfuric acid is electrolyzed between platinum electrodes, the gas liberated at anode will be oxygen, right? At anode, positively charged, so at that time oxygen will be liberated. The amount of charge carried by 1 gram of aluminium is 3 Faraday. Next we have conductivity always dash with the decrease in concentration. So conductivity decreases, molar conductivity increases with the decrease in concentration. Conductance unit is ohm inverse, or you can say Siemens. Conductivity unit is your Siemens meter, then Siemens meter inverse. Then standard hydrogen electrode consists of a platinum electrode. Okay, so I think that's all in this. So we have done all the 1 marker questions. If you have any doubt in any question, please put down in the comment section. I'll definitely address to it. And thank you for watching and all the very best.